Okay, so how does half-life relate to rate? So half-life and the rate constant of nuclear reactions are actually have a relationship with one another. So this only applies, so this one that we're talking about here, the K times the half-life of a nuclear decay is equal to 0.693. So it's important that these are only applicable to first order reactions, which is why we can apply them to nuclear reactions. So keep in mind, this is another error that I see. This T half-life, or T to the exponent half, this is not an exponent. This is just the symbol for half-life. So it's just K times the half-life is equal to 0.693. So let's take a look at an example. So we have the radioisotope for lead-212 has a half-life of 10.6 hours. What is the rate constant? So it's asking us to solve for K for this isotope. So first of all, the rate equation for this, or the rate expression, would be R is equal to K, and then we have lead-212 to the exponent 1, because it's a first order reaction. So we want to solve for K. So we don't have any experimental data to go by, but we do know that K times the half-life is always equal to 0.693. So if we plug in the half-life being 10.6 hours, right? So K is essentially 0.693 divided by 10.6 hours. We end up with a value of 0.0654 per hour, right? So there's actually, it's unitless in the numerator. So you only have a denominator value. So again, the K value, the K units, will depend on what this is. Remember, the half-life can be in seconds, in minutes, in annuals, which is like years. It can be whichever unit it happens to be. Every isotope is different. So if we write out our rate expression, it becomes R is equal to 0.0654, oops, per hour, lead-212 to the 1. Right, so we're simply solving and putting in our K value.